In this question, it's an old Mechanics 2 question from 2016, and it's no problem using these questions as long as you make sure that the questions you do use still appear on the new specification. I'm extending this question somewhat to involve a question on forces, but we do come across these later on in the course. A particle of mass 4 kilograms moves along an x-axis when t equals 0, from the point where x is 3. At time t seconds, the velocity is given by 12t squared minus 7kt plus 1. K is a constant, which means it's a number, so we need to be careful of that when we're integrating and differentiating. And when t equals 2, the displacement of the particle from the origin is 16. Determine a value for k. Well, in this case, we seem to have a lot of information about displacement, and we have an expression for velocity. And from previous videos, I know that to get displacement, we can integrate velocity with respect to t. So substituting in, we get the integral of 12t squared minus 7kt plus 1. So integrating, we'll get 12t cubed over 3 minus 7kt squared over 2 plus t plus our constant of integration, because remember this is an indefinite integral. Now we have two unknowns here, c and k, so I'm assuming that we have some initial conditions, i.e. when t is 0, x is 3, so we can use that straight away. So using t equals 0, x equals 3, we can say that 3 is equal to, well, t0 into that expression will give me 0, into the second expression will give me 0, and subbing into t will also give me 0, plus c. So immediately I can see that 3 is equal to c. So rewriting my displacement equation, I'm going to get, 12 over 3 is 4, t cubed, 7 over 2 is 3.5 kt squared, plus t plus 3. Now we still don't know what k is, so there must be more conditions we can use. And reading further down, I can see when t is 2, the displacement is 16. So when t equals 2, I can state that x is equal to 16. So substituting in, 16 is equal to 4 lots of 2 cubed minus 3.5 kt squared, 2 squared plus 2 plus 3. Simplifying, I can see that 4 lots of 2 cubed is 4 eighths, which is 32. 3.5 times 2 squared is 3.5 times 4, which is 14k, plus 2 plus 3, so plus 5. Rearranging, 14k will equal 32 plus 5, which is 37. Take away 16 is 21. So k comes in at 21 over 14, or if you divide through by 7, 3 over 2. So I can then state that k is 3 over 2. So that's part A. Part B then says calculate the magnitude of the force acting on the particle when t equals 5. Well, when you've got forces, you've got masses, and you want acceleration, and you've got an acceleration kick around, we can use Newton's law of F equals ma. Well, we have our velocity expression. We've got v is equal to 12t squared minus 7kt plus 1. Now I know if I want to get from velocity to acceleration, a is equal to dv by dt. So if I differentiate this, dv by dt will become 24t minus 7k. Now I already know what k is. It's 3 over 2, so that's 24t minus 21 over 2. So my acceleration is 24t minus 10.5. Now I know that F is equal to ma. My mass of my object is 4. My acceleration is 24, and I think it wanted it after 5 seconds. Yeah, t equals 5. So 24 lots of 5 minus 10.5. And when you calculate all that, I think you find the force applied on the object is 438 newtons.